Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. In a geometric series, T3 is 32 and T6 is 4. Find A and R, and hence find S8 the sum of the first 8 terms. Okay, so in this one, there's two ways you can start it off. You can know that the general form of a geometric sequence is AR, AR squared, AR cubed, and so on and so forth. Or if you forget that, which of course we're all human, we do forget, you can go back to here, okay? So Tn is equal to AR to the power of n minus 1. Okay, so therefore T1 would be equal to AR to the power of 1 minus 1, which is A to the power of 0, which is A, because anything to the power of 0 is 1. Okay, T2 would be AR to the power of 2 minus 1, which would be AR. T3 would be AR to the power of 3 minus 1, which is AR squared, and so on and so forth. Okay, so if you do forget the general form of a geometric sequence, not the end of the world at all, you can develop it from here. Okay, so I am going to just backtrack to the general form. So T3 is equal to a 32. So that's T1, T2, T3, T4. I should have kept going to T6. AR4, AR5, AR6, and so on and so forth. So that's T5, that's T6. Okay, so I have T3 in the question. So now I know that AR squared is equal to 32. And I know that T6, where am I? AR5 is equal to 4. Okay, so you always end up combining these two in some format. Here, it looks like division is going to be probably the easiest way to go. So let's try that one. And the reason I say that is 30, well, it doesn't really matter, you get a fraction here, but this side is more important. I know if I divide these, I'm going to get A and A to cancel. Okay, which leaves just one unknown then, or I can solve for or, and then I can go back and find A. So let's do that. Let's go, doesn't really matter which way I do it. I'm wondering, will I go AR5 over AR2? Let's do that. Is equal to 4 over 32. So because I put this one on the top, the 4 also has to be on the top. He cancels. And then using the rules of indices, when you have the same base number, you subtract the powers. Okay, so I am getting there or to the power of 5 minus 2, so or to the power of 3 being equal to, let's reduce him down, 4 into 4 goes 1, 8, 16, 24, 32. I'm getting an eighth. Okay, so if I get the 3 root of both sides, I am going to be able to solve that for or, which I presume is a half. You know what, let me double check it. Yeah, it's a half. So that's how I find my or. Okay, so then you go back to either one of these. It's a bit like simultaneous equations. We go back to either one of these now with my or being equal to a half, and we solve for A. Okay, it doesn't matter which you go back to. I'm going to pick this one because it's less ors, so smaller numbers. So sub in to get A. So we know AR squared was 32. So A times a half to be squared is 32. A is 32 divided by a half squared. Half squared is a quarter. It's going to be a fairly big number. 32 divided by a half squared. is 128. Okay, not too surprising. It feels right because I can see the sequence is going down. Okay, so obviously T1 then was bigger than 32. So yeah, 128 could indeed be right. Okay, so then let me add in a page. We were asked to find S8. So you're going to use the sum of the first n terms. In this one, it's geometric sequence. So Sn equals a times 1 minus r to the power of n over 1 minus r. Let me just double check that again. 1 minus r to the power of n. Yeah, a is my first term, which I just found to be 128, or is your common ratio, which we also found. So it's equal to 128 times 1 minus a half, and I'm finding the first 8 terms, so n is 8, over 1 minus a half. So let's put that into the calculator and see what we get. So 128, let me hit the fraction button first, 128 bracket 1 minus a half to the power of 8, close my bracket, 1 minus a half again on the bottom. So 255 is what I'm getting for the first 8 terms. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.